guys, welcome to my channel. So today I'm going to be talking about simple harmonic motion part 2. So if you want to follow up in this simple harmonic motion, you need to go and watch the part 1 so you can follow up with us in the part 2. So without much time wastage, let us get to the video. So please don't forget to subscribe, like and comment. Thank you. Alright, let's go to the video. So in this part, we are going to be talking about definition of terms. So we look at the meaning of amplitude. Amplitude is the maximum displacement of a body performing simple harmonic motion, and the SI unit for amplitude is always in cm or in meters. Know that amplitude is the maximum displacement of a body performing simple harmonic motion. Now we move to period. Say period is the time taken for an object to complete one revolution or cycle, and period formula is equals to T is equals to small t, which signifies period is the symbol for period is T is equals to small t over L. The SI unit for period is seconds. Then frequency is the number of complete revolution per second, and you see this is the formula. It's measured in hertz. Then move to speed acceleration of a simple harmonic motion. So move to angular velocity. Angular velocity or angular frequency is the rate of change of an angle with what? Time. So with that, you know the formula. The formula is W equals to rate of change, which is theta over t, and then the SI unit for angular velocity is equals to radians per seconds. So we have that. You can also see that theta is equals to angular velocity times time. So this is radians per seconds form, as in this is SI unit. So just take this one, know that this, let us call this equation x, we are going to be using to find other things. And then you look at arc length. Arc length is equals to r, that is radius all over theta, and you can see that theta is equals to s all over r. Yes, and then move to linear velocity. Linear velocity is stated as v is equals to, we all know that linear velocity is equals to displacement over time. Velocity is equals to displacement over time. Then we now from x, as we described here, to become x. We now say that this is equals to this. This is our equation we brought at that time. So we see that angular velocity is equals to theta over time. So we just brought it here. We want to use it to simplify this linear velocity, because we cannot use this formula to solve. We want this formula to solve for linear velocity in simple harmonic motion. You have to have this formula connected to the word simple harmonic motion. So we now solved it. We now have that t now is equal, when you cross multiply, you have that t is equals to theta all over angular velocity. Then we now have from equation y, which is this equation here, now say that theta is equals to s all over r. Then you can now see that s is now equals to theta over r. Then you now say, since velocity is equals to displacement all over time, you can now see that is now equals to theta all over r, theta times r over theta over w over angular velocity. So we now have that when you divide, we now have that velocity will now be equals to radians times angular velocity, or you can still call it this formula. So with that, we call it a day for part 2, and watch out for part 3. I'm going to be talking on more related topics on simple harmonic motion. Please do not forget to subscribe, share, comment and like. Bye bye.